that's on the sheet, the first thing that I would do is I would restrict the domain. Okay? Now, understand this. The reason that you're restricting the domain is I would hope that long ago when you were in elementary school and learned how to divide, they told you that you couldn't divide by 0. So all of the values that are going to make my denominator 0 need to be restricted out of my domain. Not negative, sorry. In other words, if I put d over 2 in for x, I get d minus d, which is going to give me 0. If I put negative b in, I get 0 in the bottom. If I put e in, I get 0 on the bottom. So these three are going to restrict my domain. The problem is when you go to find your range of your function, you have to wait until the end. Because in order to get your range, you have to wait until the end to see what your graph is going to look like, and then see what y values you can't get out. And you would have to restrict your range at the end.
You just go crazy.
Once you have your once you have your domain restrictions taken care of, at every restriction in your domain, you will have some glitch in the graph.
Some glitch in the graph.
And that glitch in the graph is either going to be a vertical asymptote or it's going to be a hole.
No, I just started a video and ended it like the first minute of the caylee hermsen.
So,
hey Kaylee, come back a track.
my advice is to find the holes first.
Holes first.
And the vertical asymptote second. Your holes basically are values that will cancel. Vertical asymptotes don't.
I remember doing this. Like I feel like I know how to do this already.
So these are going to cancel. So I know that the x value of my hole is at negative b. Okay. The reason I can't put negative b into the original function is because I get negative b minus b will give me a 0 on the bottom. But now that I've canceled that factor on the bottom, substituting negative b is no longer an issue. So the y value of the whole is this evaluated at negative b. So if I put negative b in for x, the first term I would have negative b plus a. The other one I would have negative b minus c. On the bottom I would have negative 2b minus d and negative b minus e. And that's going to be the y value of the whole. Okay, so basically to find the holes, once you've determined the x value of the whole, to get the y value, you put that value into your equation into whatever is left. My vertical asymptotes are going to be at d over 2 and e. Because those were the factors that made the bottom 0 that don't cancel out. X-intercepts and y-intercepts. So my x-intercepts happen when my y value is 0. And what you need to understand is if I set this equal to 0, the only time that a fraction is going to have a value of 0 is if the top is 0. So my x-intercepts in this problem will be at negative a and c. because those are gonna make the top 0. And I would have 0 over some number in the first one, and I would have 0 over some number in the second. To get my y-intercept, I sub 0 for x. And if I put 0 in for x, 0 plus a is a, 0 minus c is negative c, 0 minus d is negative d, and 0 minus e is negative e. So all I do is I take the stuff that's left and I put 0 and I substitute that in for all my x's. And what happens is all your x terms are gone and you're just multiplying all of the constants. And behavior. And behavior looks at the highest power, or if you've forgotten the term, the degree in the numerator So I take a look at the degree in the numerator and the degree in the denominator, and you're going to compare those two. Your first possibility, your end behavior is y equals 0, and that happens if the degree in the denominator is bigger than the degree in the numerator. Learn to write. Hold on. Y equals the quotient of the coefficients of the degree term if they're the same. My degree term, or my highest power term, is going to be when I multiply the x's together. So in this one on the top, to get my degree on top, x times x times x is x cubed. 2x times x is 2x cubed. So in this one, highest power on the top is the same as the bottom. So I make a fraction of the coefficient. So in this one, my end behavior would be y equal 1/2, because that's the quotient of the coefficient.
Hey, do the blinds close? Because there's a water there and I can't see the board.
I can't close my blinds.
Okay.
Don't worry, Eli. I have a video if you want it.
I'm fine.
Okay.
Or slide over. And then my last option, y equals this, if my degree is smaller on the bottom. Okay, so the first case I have a horizontal at y equals 0. The second case I have a horizontal at y equal 1/2. The final case is going to be an oblique asymptote. And the way that you get that, polynomial long division. And then when you go to sketch your graph, plot everything. Okay, so all of this stuff, purpose of finding all of that stuff is to be able to graph it. So put in your x-intercepts, put in your y-intercept, put in your holes, put in your asymptotes, put in your end behavior, and then based on that graph, or that information, you should be able to sketch your graph. Good.
Should we stop videotaping or keep videotaping? I don't know what to do. Hold on, Kaylee.
Alright, first thing you have to do, factor it. Get x squared plus x minus 1, bottom is x plus 2, but x minus 1, and then I have a factor.
You should just hold on for one moment. Or not. It's fine. It doesn't matter. It doesn't help.
Restrict my domain. Can't put in -2. Can't put in 1. The range I have to come back to later. Holes. Look for stuff that you can cancel. Because I canceled that, I know that I have a hole at 1. If I put 1 into what's left, 1 squared is 1, with a negative is -1, 1 and 2 is 3. So at 1 and -1/3. So if I'm here, I go over 1, I go down a third, there's the hole. The other one then, the vertical asymptote. Over here at -2, I have a vertical asymptote. My x-intercepts happen when the top is 0. Top is going to be 0 when I put 0 in. Here's the problem. If I put 0 in for x, I have 0 divided by 2, which is still 0. So my x-intercept and y-intercept both occur at the origin. So I know I have a point at the origin. Now, the other thing that you should know, as an aside, do you agree that if I have y equal x, that equation looks like this, and at 0 it crosses the axis. But if I go in and I look at x squared, 0 works for both factors, right? But then when I look at x cubed, it goes through again. When I look at x to the 4th, it doesn't. So if you think about it in terms of crossing the axis, if I have something that occurs an odd number of times, it'll cross. If it's an even number of times, it doesn't. Because when I get this solution, it crosses there. If the solution happens twice, it's like it crosses and crosses back in the same point. So instead of crossing the axis and going down, it crosses and it crosses again. Here, it's like, I'll go up and then I'll come down and then I'll go back up again. 4 times, it crosses, 2, 3, 4, comes back up. So because of that, and I have x squared in the top, and because my hole is down here, I know that this graph is going to go through the hole, it's going to hit this point, and it's going to come back down. Okay, it's not going to cross because 0 is going to work twice here. Alright, in behavior, my power is higher on the top than it is on the bottom, which means I need to do long division to find it. I take negative x cubed plus x squared divided by x squared plus x minus 2.
Oh god, okay, hold on.
I have to use long division and not synthetic division because what I'm dividing by is not linear, it's quadratic. Plus 0x plus 0. Inside you have to account for all of your powers all the way down. So if I take negative x cubed and I divide by x squared, I get negative x. So then when I multiply this times this, I have to distribute. So negative x times x squared, negative x cubed. Negative x times x, negative x squared. Negative x times negative 2, positive 2x. And when you divide, you subtract the 2 lines. So if I subtract those, they add out. 1 minus negative 1 is 2, so 2x squared. 0 minus 2, negative 2x. And then I bring down my plus 0. 2x squared divided by x squared is 2. If I distribute this in, I get 2x squared plus 2x minus 4. And I have to subtract.
Wait, how do you get the 2 on top?
I take this, divided by that. I need to have the same thing underneath, so when I subtract, I cancel. So 2 minus 2 is going to drop. Negative 2 minus 2 is negative 4. 0 minus negative 4 is plus 4. And I'm done. And I know that I'm done because this power is smaller than that power. So my end behavior is going to be y equal negative x plus 2.
That was a good question. Negative 4.
I don't know. I don't care about it. It has to do with infinite limits. Okay, so if I graph this line, I have a y-intercept of 2, slope of negative 1. That line is going to come down like that, and continue on like that.
That's all we're done graphing?
Now I just need to sketch it. So I it's gonna turn around here. I know that it has to go through this hole. I know that it has to come closer to the asymptote. I also know over here that once it touches this point and turns around and goes back, it's gotta get closer and closer to that asymptote. Okay? If it's down here, it's up on the other side of this asymptote. So that one is gonna have to turn around. So now that I have my graph, I can do my range. I can get anything I want except stuff that's in between here, right? I basically have a gap in the graph. So my Y values can't be between 0 and something. Put that in your calculator, graph it, and you are going to have to calculate this minimum value.
Someone else can do it. Good luck at Mr. Digman. You want to tell Kaylee good luck at state? Not feeling it? Do you want to tell her good luck?
Good luck at state, Kaylee.
Nathan, you want to tell her good luck at state?
Good luck at state.
Already said it, but good luck.
Good luck.
Good luck.
Okay, we're done.